So this video is about digital graphics and we'll focus on how the exam questions work. To store a graphic digitally, you need two things. You need the resolution of the image and you need the number of colours you're going to store for that image. The resolution of the image is stored in pixels, and each pixel represents one dot on a computer screen. The more pixels you have, the higher quality graphics you have. The number of colours is measured in bits. One bit gives you black or white. One bit lets you store two colours, so 2 to the power of 1. 2 bits let you store 4 colours, 2 to the power of 2. One of the key things you need to be able to do is to calculate an image size. So to calculate the resolution, the resolution is simply the screen width times the screen height. All the measurements are in pixels. So a monitor that's 1280 pixels wide and 800 pixels tall can display 1280 times 800 equals 1024,000 pixels. To calculate the number of colours, this is called the colour depth. This is 2 to the power of the number of bits per pixel you're given. So if you're given 1 bit per pixel, it's 2 to the power of 1, that's 2 colours. 2 bits per pixel, 2 to the power of 2, 4 colours. Notice the pattern. Every time you add another bit per pixel, you end up doubling the number of colours, and they could ask you to go the other way. So if you reduced it from 5 bits to 4 bits, you would go from 32 colours down to 16. All of that helps us understand how we can start to put together the image size and eventually the file size. Okay, so what do we need to do to actually calculate the image size? Well, it's a fairly easy process. The image size in bits is the width of the image in pixels times the height of the image in pixels times the colour depth. There's an example for an 800 by 600 pixel image with 4 bits per pixel. Notice you have to do 2 to the power of 4. Don't just multiply by 4, but it has to be 2 to the power of 4. So 4 bits per pixel means every single pixel has 4 bits associated with it. You might be asked to give that in different units, megabytes, kilobytes, possibly gigabytes. Just be careful, remember the conversions. If you're going from bits to bytes, you have to divide by 8. If you're going any further, you need to start dividing by 1,000. Make sure that you show your working in the exam, because some of these numbers are quite large, it's quite easy to make errors. And if you can show the working, you'll at least get marks for the working, even if you might make a mistake in the actual final thing. So here are some very typical exam questions for you. Have a go at these. They are the sort of thing that they'll ask. The only thing that's missing from there is that they might ask you what a bit is, but I think that's pretty easy when it's a dot on the screen. But have a go at the other questions here, because these are really, really typical ones. Pause the video, have a little go. Here are the answers. So notice the use of the very simple equation, the height times the width in pixels, multiplied by 2 to the power of whatever the colour depth is, so 4 bits per pixel here. We've got a conversion to megabytes here, so dividing by 8 to get from bits to bytes, and then dividing by 1,000 twice. And then you've got this question about what impact increasing the bit depth from 4 to 5 pixels will have on the graphic. Well, it increases the number of pixels from 16 to 32. And then finally you've got this black and white image working out the binary representation of each line.